In this question, we have a golf ball being hit. It is travelling 160 metres in a curved path, and it's then landing in a pond that's 5 metres lower than where it was hit from. Now, we are asked to find the speed of the ball just before it hits the water. Now, the first thing I notice in this question is that we've been given the mass of the golf ball, but it's in grams. So we're going to start by converting that to kilograms. So that's 0.0459 kilograms. For this question, we're going to need to use increase in kinetic energy plus the increase in potential energy is equal to the work done. So let's start with the increase in kinetic energy. So this will be the final kinetic energy, subtract the initial kinetic energy, and we're going to use our half mv squared to find these. So now we're going to consider our increase in potential energy. Now this is travelling from a height downwards, so our increase in potential energy is going to be negative. So we're going to use our mgh, so my m is 0.0459. I'm going to use g is equal to 10 and my height is 5 metres. To calculate my work done, I'm going to look at the resistance acting on the ball, which is 0.3, and the distance it's travelled. So we do the force multiplied by the distance. It's going downwards, so this is going to be negative 0.3 times 160. So to be able to get V, I'm going to need to rearrange this. So I've simplified it a little bit, and this is going to rearrange to V squared is equal to 508.4. So V is going to be equal to 22.54, which if we give it to 3 significant figures, will be equal to 22.5 metres per second. This question now continues for part B. So it's now hitting the water, and we're told that the water is absorbing 8 joules of energy from the ball immediately. It's going to sink vertically downwards to the bottom of the pool and come to rest. And the resistance on the ball is going to have a magnitude of 3 newtons. We're asked to find the depth of the pool. So the first thing we're going to consider is that the energy at the point of impact is going to be equal to our half mv squared. It's just kinetic. So we worked out the V in the previous part, that was 22.54, so we can work out the energy. And it's really important at this point to use the exact value from the previous question, so make sure you stored it in your calculator so you don't lose any accuracy. Now we can bring in our 8 joules. We know that the water is absorbing 8 joules, so we're going to subtract this from our energy. So to be able to work out the depth of the pool, we're going to once again use increase in kinetic energy plus increase in potential energy is equal to work done. So our increase in kinetic energy, so we're going to be doing our final minus our initial. The initial is that 3.66 that we just worked out, and the final will be 0 because it's coming to rest. So our increase in kinetic energy is going to be minus 3.669. Our increase in potential energy, so this we're going to use mgh. Once again, we're going from a height downwards, so it's going to be negative. So I've got the 0.0459 for m, I'm using 10 for gravity, and I'm using d for the depth of the pond. Lastly, we've got the work done. So this is going to be the magnitude given in the question, which is 3 newtons, multiplied by the depth of the pond. Again, we're going downwards, so I'm going to use a negative 3. So lastly, we just need to rearrange this and get d equals. So once we've rearranged this, we should get d is equal to 1.44 metres, and this will be the depth of the pond.